us today. My name is Ksenia and I'm the Kotlin Marketing Manager for Education. Today we're presenting a Creating a Kotlin Course from Scratch webinar. This is the latest one in our educational series created by educators and for educators and learners. In these webinars, we talk about teaching Kotlin for different programming topics. We also try to provide you with some practical knowledge of how to integrate Kotlin into your teaching and learning. I'm excited to introduce today's speaker, Márton Braun. He's a Google developer expert for Kotlin and Android and currently works as a developer advocate at Stream. Márton will be talking about introducing Kotlin to the curriculum at the Faculty of Electrical Engineering and Informatics of the Budapest University of Technology and Economics. There he updated the Android-based software development course from Kotlin to Java, and then built a standalone university course to teach the Kotlin language. Márton will also talk about how the Kotlin course is being run, including the all-live demo approach he uses for engaging lectures, the wonders of teaching remotely, and the students' reception of the language. This webinar is recorded and will be available to watch later in our Kotlin for Education playlist on this YouTube channel, along with the previous webinars of the series. We really want this to be a participatory experience, so please share any questions and comments in the chat. We'd love to hear from you, and we'll have time at the end of the webinar to address your questions. And before we start, please tell us about yourself, where you're coming from and what you do, whether you are an educator, a learner, a developer. Please let us know in the comments. And that's it. Now, please welcome Márton.
Thank you so much for the lovely introduction. Let's jump straight into it then. Seeing how I've already been introduced, I won't do that again. A quick note before we start, I'm feeling a bit under the weather, so if my voice sounds weird, that's the reason for that. And also, I usually give more technical talks. They usually involve more coding. So this, in comparison, is going to be more of a story time thing. But hopefully it also goes all well. All right. So our story starts here, which is Budapest, Hungary. And within that, it starts at the University of Technology and Economics. And within that, at the Faculty of Electrical Engineering and Informatics, and within that, the Department of Automation and Applied Informatics, which sounds very specific, but that's the precise way of putting it. So this department has been working on educating people about mostly, a lot of software development topics, but one of their main focuses has been mobile development. I want to give you a bit of a timeline for that. And I would actually have to start this timeline way back. They have been teaching things like Symbian even back around 2005 when I was roughly 9 years old. So I obviously wasn't present for that, but the point is that they have been teaching mobile development related things for a very long time. And where I want to start today is 2011, when they launched Android and iOS courses at the university as elective courses, which means that any student could sign up for this as long as they managed to fit into the limits of the course, which has been something important because these courses have traditionally always been completely full. They have been very popular. Then the next year, there was a really important book released by people working in the department about Android development, written in Hungarian, covering Android development at the time, and this was important literature there for several years. The next important step was in 2015 when a minor was introduced for the master's degree in computer engineering at the university. So if you're attending the master's there, you have to pick a major and a minor. And for your minor, since 2015, you could pick mobile software development. Which meant 4 different courses, which focused on iOS, Android development, and a lot of practical industry things. And it's worth noting that ever since it's been introduced, it has always been the top choice among students who are doing a master's degree there. It has been the most popular minor overall. Then the next year, mobile and web development has entered the bachelor's curriculum. So you can see the very first slide of that course here, which is asking in the title, mobile and web development in the bachelor's curriculum, and then states a very happy yes on the first bullet point of the slide. So this was super exciting. Ever since this course was introduced, every year, more than 400 students who are doing a bachelor's degree will now learn a bit about Android development. So that has been the story of mobile development at the department before I was around. And as a student, I signed up for the Android course in 2016. I was also doing this brand new mobile and web development course at the same time. And I've thoroughly enjoyed this. This is where I encountered Android development for the first time, and I have become an Android developer as a result of this course. So obviously it has went really well. I've also encountered Kotlin while learning things for the Android course, just somewhere on the internet. I can't remember anymore, unfortunately. But I did spend the next year learning Kotlin extensively. For my project courses, I chose to implement a Twitter client for Android written in Kotlin. I also wrote a DSL library during that same project course, which somehow is still my most popular project on GitHub to this day. And I also wrote my bachelor's thesis, which was a Kotlin web framework based on Kotlin JS. I also got to teach a bit of Kotlin on the very very last lectures of the Android course in 2 semesters. I got to give a 30-minute presentation about Kotlin and introduce students who have spent a semester learning Android and writing it in Java. I got to introduce them to the basics of Kotlin and why they might be interested in that. And right after I did that in 2 semesters after each other, Google I/O came around in 2017, and Google has announced official support for Kotlin on Android, which was, of course, huge. I still remember sitting at our local Google I/O extended event, which was also hosted at the university by the same department, which again shows how engaged they are in trends like this. So following up on that, the next year, I worked on converting the Android course from Java to Kotlin. This was a huge effort. Many people were involved. The Android course has both lectures and weekly code labs for students. So this meant translating a lot of slides, about a dozen different Android projects, as well as about a dozen code lab instruction materials on how to build those projects. So this was a lot of conversion from Java to Kotlin. And something that we paid a lot of attention to is to teach Kotlin features progressively during the course. So instead of immediately using all of Kotlin's features from the first week, because we had to teach Android and Kotlin at the same time, both of these things were completely new to students, we made sure that we were dropping features, some new Kotlin features on the students every week. And for example, on the first couple of weeks, we weren't using advanced things like scoping functions, or we tried to avoid nullability as much as we could, and wrote more Java-style code, perhaps. But that way, students had an easier time learning Kotlin. That was a very important part of our approach. And after doing this conversion, I also taught these code labs for 2 semesters for small groups of students. And it was really fun. I got to code in Android Studio. Students were following along on their own machines. And we basically had nothing but positive feedback on teaching Android in Kotlin. So as a result of that, in the summer of 2019, we discussed that maybe we should just have a course that's dedicated to Kotlin on its own without any of the Android things in the way, so that we could cover the language in more depth. And as that was suggested, I jumped on the opportunity. I was very happy about getting this opportunity to create a course like this. And therefore, another course was born within the department. Again, an elective course that anyone can freely take if they want, which now taught Kotlin. And this is what I'm going to be talking about for the rest of this talk. One more quick mention here for the timeline. 2 years later, Flutter course launched. So this was earlier this year, which is also somewhat a result of the Kotlin course, in that it uses a lot of the same teaching approaches that I'm using in the Kotlin course. And it's also a good example of, again, how the department is teaching current technologies that are being used in the industry. I want to have a slide here for acknowledging some of the people who have contributed a lot to these courses existing. So Peter Eckler has been the Android person at the university for a very long while. He's running the Android course, so he taught me Android originally. He was also my mentor for all of my project courses, for my theses, and so on. He's also the head of the Kotlin course on paper, so he's doing the administrative side of that for the university. Then Bertrand Forstner has also been a very important person, working a lot on the mobile development minor that's available on the masters. Hassan Sharaf has been in various leadership positions at the department and also at the faculty, supporting all of this. And then Imre Kelényi and Gergely Csúcs have been there in the early days, focusing on iOS and Symbian development. Finally, one last shout out before we get into the meat of the talk. Outsoft is an agency, a local Hungarian agency that has been spun off from the department. And they have also been very supportive of everything education related. There are many employees at Outsoft who have given lectures at the university. And this is a great connection between the industry and then the university itself. They bring back a lot of their practical knowledge that they use to ship real life projects into the classroom. Okay, so some of the goals that we had with this new Kotlin course. So first of all, we wanted to teach independently of Android. Android adds a lot of complexity. It's a lot of new things to learn for students. So we wanted to focus clearly on Kotlin. And of course, Android kind of steals the show on the Android course because we lose the focus that Kotlin can go beyond Android. It doesn't just exist for Android. It can be used in nearly anywhere. One of the goals for the course was to just build an interest in Kotlin in general. So I didn't necessarily want everyone to become a serious Kotlin expert after this course, but I did want to build a general interest so that they might pick up Kotlin in the future if they have coding projects. At the same time, I wanted to make sure that for the people who are engaged and who want to learn a lot about Kotlin, they can gain a deep understanding of the language basics. And something very important to me is that I wanted to build on existing Java and object-oriented knowledge as I was teaching Kotlin in the course. This was important because that's the perspective that I initially learned Kotlin from 4 years ago. And using things like the Kotlin in Action book, which I always have on my bookshelf. And yeah, I just wanted to take everyone else on that same journey because I've enjoyed it so much and it got me so involved in the language. Here are some stats on languages that my students spoke as they were entering the course. As you can see, Java is very highly represented here, so this was aligned with my goals, thankfully. And other than that, you can mostly see languages that are part of the bachelor's degree in computer engineering curriculum at the university, meaning C, C++, and C#. Okay, so I started the course by writing material. Everything that I teach in the course is available as written material, and all of this is written in English. This was a conscious choice. I wanted this material to be reusable and portable. I didn't want to be stuck with a lot of Kotlin content written in Hungarian that is then very hard to reuse. I ended up writing about 180 pages. That's roughly the current length of all of the course materials. And 95% of my students approved of this being in English, which means that I had 1 or 2 people each semester who had some amount of trouble with the English material. But of course, the lectures themselves were in Hungarian, and I was also happy to offer help if anyone was stuck with the English part of things. The materials, of course, contain a lot of code, but also many links, references to external articles, mostly to dive deeper into the reasoning behind the language, things like old talks from KotlinConf or old articles by Roman Elizarov or other language creators who have explained some design decisions behind the language. And of course, they feature my original illustrations. For example, here's the image that I used to explain how you can add coroutine contexts together. All right, a bonus photo. Here's me developing some of these materials. I happened to be traveling a lot during 2019 when I was preparing this. So here's me in Cluj-Napoca in a coffee place writing up the chapter about the type system and generics in Kotlin. Here's what the completed materials look like. This is what students get access to. I could go into a lot of detail on this, but I just want to highlight a few things in it. So again, progressive disclosure was very important. I didn't want to use any language features that I haven't fully explained yet. So for example, chapter 3 is nullability. Therefore, I was careful not to use anything around nullability if I could avoid it in the first 2 chapters. You can also see that chapter 2 is object-oriented programming because people were coming from a Java background. I started with that topic so that I could build this bridge between Java and Kotlin. They could see how we get from Java code to Kotlin code. And then I went for the more Kotlin features, the type system things, nullability, functional programming, the applications of functional programming in things like the standard libraries, collection APIs, and then more advanced things around the end, concluding with coroutines. I've also created Gradle projects for every chapter separately. I mostly needed these because, as I said, the chapters contain a lot of code as I'm explaining language features, and I had to write that code somewhere and make sure that it actually worked correctly and it compiled and whatnot. So I was going to do that in the IDE anyway. So I ended up providing all of these projects that I originally wrote the code in to my students as well. I was mostly doing this for myself so that, again, I can check that it works. I could also copy paste from this during lectures. But about 50% of students reported that they actually used this for learning. There were, for example, students who opened these projects during the lecture and were following along in their own IDE. As you have probably seen already, all of this is hosted on GitHub, which means that there's a fully transparent edit history and students could theoretically contribute, although I'm still waiting for the first PR that fixes typos. And something I want to highlight here is that István Juhos has contributed a lot to this course. He was my main reviewer when I was initially preparing the materials, and he's also the substitute lecturer of the course when I'm traveling and I can't be there when the class is supposed to take place. So again, someone without whom this course wouldn't have been quite as easy or possible. Okay, let's talk about the lectures. So this course was only lectures because I have limited time and resources. So I didn't have time to, for example, have weekly code labs with all the students. And my lectures had 0 slides. As much as I love creating things in PowerPoint, these Kotlin lectures had 0 slides. And the reason for that is that instead it was all live coding. So a typical lecture looked something like this. We were just sitting there looking at IntelliJ, and I was coding away, showing off language features and explaining things around the code. Why live coding then? I believe that the IDE is a core part of the Kotlin experience. If I had to write Kotlin somewhere outside of IntelliJ, the experience with the language just wouldn't be as great as it is this way. I don't know if anyone here remembers the old Kotlin Lang website back in 2018. It had this awesome picture of the lighthouse on Kotlin Island back then. I really miss this from the website. Maybe someone in JetBrains can do something about that. Anyhow, my point is that one of the pros that was listed back then on the website as like a major factor for Kotlin is how tool-friendly it was. So the language is designed consciously to enable strong tooling for it. And of course, IntelliJ is a very, very capable tooling for it. And for educational purposes, of course, IntelliJ is free, both for teachers and for students. So all of my students can just use the Ultimate Edition by using university accounts. So this is approximate depiction of what lectures looked like. I was sitting at the desk in the lecture hall. I was live coding and presenting that to students, and they were following along with it. This was great because I got to do this in the same way as they will be coding later on when they're using Kotlin, and also the same way that I code in my day job in Android Studio. This format of coding while students are following along is also great for encouraging questions. So because I have the code right there and I'm editing it, students can ask things like, could we also do this? Or could we also use this other syntax? What happens if we modify the code in this and that way? And because I just have the ID there, I can immediately modify it, and we can just see for ourselves if it compiles, if it behaves correctly, and so on. Let's look at a couple of IDE features which I found particularly useful for teaching. So, for example, there's this intention action that you can trigger on any declaration to specify its type explicitly. This has been really useful for teaching things around the type system. I can basically use this in the IDE to show students what the compiler is inferring as the type of an expression. So I've used this a bunch. And there's actually a better way of doing it. There's a shortcut called type info that you can invoke on an expression, and then you don't have to modify your existing code. You can just get this tooltip that shows the type of the current declaration. Something you also see on this slide is this overlay that I actually have show up in my IDE to show all of the shortcuts that I'm using during the lectures. Again, this teaches an important aspect of coding for students. They can pick up on these shortcuts and also use it when they're coding. And I actually daily drive the IDE with this plugin turned on. I get confused when I hit a shortcut now and this green thing doesn't show up on the bottom of the screen. So this is called something called Presentation Assistant. It's a plugin for IntelliJ. And if you ever give presentations when you're hitting keys inside the IDE and presenting that, you should probably have this installed. Other useful things in the IDE include the debugger. Being able to stop the code during execution and then easily inspect values in there and even code new expressions and execute them while the program is paused is a really powerful teaching tool. And you also get access to things like a stack trace. So here's on the slide an example of me teaching what tail recursion is in Kotlin. And I got to just show the different stacks that are built in the different cases. Instead of trying to just explain it and like trying to draw these stack frames, I could just show it in practice in the IDE actually working. Another thing I love doing is jumping into implementation, especially for standard library features. Because Kotlin is open source, I get to do this for anything that I want to, and I can jump around in the code of the collections implementation, in the standard library and all of the various extensions and useful constructs in there. And I can show students that none of these are magic, that they can also browse these when they're coding and they can dive into that code and understand it. I think this is super important and extremely valuable to learn from. Another thing that goes under the hood of Kotlin is the Kotlin bytecode viewer inside the IDE. I keep using this SKB shortcut in Action Search to open this panel in IntelliJ. And this lets me both view the generated bytecode, but then also decompile it and translate Kotlin to Java, sort of, for my students. Again, something extremely useful. I've used this, I think, on every single lecture that I've taught, and students always enjoy this. I like this feature so much that I've given a talk just about decompiling Kotlin code before. So this and everything else that I'm mentioning will be in the references at the end of the talk. Some more things that are really useful for learning, but I don't use directly in my lectures. There's the Java to Kotlin converter, which is great when you're starting out. You can take existing Java code, and even if you can't write that piece of code in Kotlin, you can take the Java code and have it converted automatically for you. And then Kotlin scripts and the REPL are great ways of quickly iterating over Kotlin code. Right, so as I said, this was the usual setup of live coding. In these lectures, I was showing the material that I've written before, that I've already discussed, and also some extra things outside of that. For example, new developments in the language, interesting news about Kotlin were often mentioned on the course, and so were events, both things like international events, so that students could, after the event took place, go to YouTube and watch the talks that were there, and also local events. And I was also quite successful with this. I had students show up at local meetups about Kotlin, and that was also, as you might expect, very satisfying. This in-person thing also offers very easy interaction. Not only can students ask things like, can we also try this other thing in the IDE or modify the code somehow, but I also get to ask them things. For example, if I'm explaining a feature in relation to something in Java or something in C# or Swift, I can ask my students like who here has used C# before, and then get a general idea by raise of hand of how much people are following what I'm saying. And then in the second semester of the course happening, the funniest thing happened, and we had to go all remote, which was a shame. But it was something that everyone had to deal with. So here's some of my observations about remote teaching then. First of all, recordings became essential during the remote classes. I did start these already when giving the lectures in person, but I was mostly doing it as a backup and for myself to review later. I was maybe gonna publish it for students, but I didn't get to it until we had to go remote. However, at this point, it became very important that students can get recordings of the lectures later on. So one of the things I made sure that I was making them available very quickly. Lectures were from 12 to 2 p.m. and around 3 or 4 p.m., so an hour or two later, I have already published the recordings of the lectures. This encouraged students to watch it immediately on the same day as when the lecture took place, instead of like waiting around collecting all of these and just like binging them at the end of the semester. I also made the recordings available in multiple forms. So there was an official Microsoft platform that the university is using for lectures. I uploaded it there in case students are using it for many different courses. But I also uploaded the raw files that students could download, and I also uploaded all of the lectures on YouTube. And all of these had users. There were people telling me that they couldn't stream from Microsoft, but YouTube streams worked well for them. There were students who told me that they downloaded the files and they were watching it like on the train when they didn't have an internet connection and so on. Overall, after going remote, 90% of students said that they were watching the recordings of the lectures. Then the classes themselves took place over Zoom, which is exciting and it works fine for the most part, but it gets very hard to get interaction from the students. So I mostly got questions and interaction over chat, which was okay. But there was occasionally a person brave enough to just interrupt me via voice and like talk to me and ask questions, which I was like very funnily but very happy about. And I also focused a lot after we went remote on over communicating to the students. So whenever deadlines were coming up, whenever important things were happening, I would communicate them through multiple channels so that I was sure that they got all of the important info. This was important because in person, about 2/3 of the students attended the lectures, but this dropped to about 1/3 when we went remote. Overall, with these things implemented, 96% of students said that they had no trouble learning this course remotely, which was, I think, success. There are two kinds of requirements within the course. One of them is a homework project, and the other one is a written test. Both of these contribute half of the grade. Let's start with the homework part of things. Students have a free choice of what project to implement within my course, as long as it's not Android, because Android is already covered by a lot of other courses, and we didn't want to have conflicts with them. And since it's a free choice, this meant that students got to pick projects that had varying difficulty. Some students might pick relatively easy things, and this was good for students who just had a casual interest in Kotlin, but didn't want to spend all of their time in the semester on a relatively small elective course. But if someone was very involved with Kotlin and they were interested in building something cool in it, then they could also pick up a larger project and build that. Since there were different difficulties, I didn't grade on the complexity of the project. Instead, I graded on two things. One of them was to create something meaningful, something practical, like write some code that does something. And then the other part of the grading was to use Kotlin as nicely as possible. I also provided some starter projects for my students. as project setup can sometimes be troublesome if they don't know the IDE or the environment well enough yet. So I had a command line basic Gradle project and then a bunch of different projects for supporting GUI-based applications. About 50% of students ended up using these starters. The largest setup problems were usually JDK versions, so having to debug that students have different JDK versions in the IDE, in Gradle, on the command line, and so on, as well as missing JavaFX support in a lot of cases. This was happening when students were using OpenJDK distributions, certain ones, as well as JDK versions above 8. And notably, they never had trouble installing the IDE. They only ran into problems later on, usually something around JDK versions or Gradle. Okay, just some brief mentions of types of homework assignments that students tend to hand in. So at the very basic, they can create a bunch of Kotlin classes with idiomatic operators following language conventions, and then have those unit tested. That's the easiest thing that you can get away with for a homework assignment. There were a lot of people building various REST and web services. Some of these were Spring Boot applications, but a lot of students picked up the Cater and Expose stack. Notably, the course itself only teaches the Kotlin language. I don't teach any of these frameworks, but a lot of my students were able to pick up both Cater and Exposed on their own and produce nice working applications with them. Then there were all sorts of games, Minesweeper, Tetris, Game of Life, and other things implemented. I've seen integrations with video games that had open APIs. I've seen image processing applications, and also some data analysis stuff, which was a great usage of Kotlin's collection processing capabilities. Let's move on to the testing part. So after everything I said, you might not be surprised by this, but the tests were not super hard. Again, the point was not to tire students out. And I'm not just saying that they weren't super hard. I also heard this as feedback. There were students telling me that the test could have been harder. I don't know how many people get that kind of feedback, but that's what I got. On the tests, there were a lot of quiz type questions, which are fairly self-explanatory. A bunch of open-ended questions, for example, describe what a data class is and things like that. And while the tests were taking place on paper and not remotely, I also had some coding questions. For example, take this code snippet and rewrite it using the apply function of the standard library. So yeah, mostly I was just checking that students had a good core understanding of basic Kotlin features. However, my favorite kind of exercise on the test was analyzing broken Kotlin code. So my setup for this was that someone allegedly wrote this code without sufficient knowledge of Kotlin, and they should mark and fix as many mistakes as they can. And I would present students with code examples like this, which looks a lot like Kotlin code, but if you start looking at it a bit more closely, you'll see that it's riddled with mistakes. This has been very successful, and it was great to measure students' Kotlin awareness, but it was surprisingly hard to come up with sufficiently broken code to use for these exercises. Moving into some stats, you can see here the number of students who have signed up for the course each semester. We had a limit of 120, and every semester, every subject, every course has some students who drop out right after signing up. So basically, for 3 semesters, we were at maximum capacity. The only semester where I've seen a drop in the number of students has been the one that was the first semester to be fully remote. So obviously those were not normal circumstances. The point in general is that more than 400 students have taken this course over these 4 semesters, and the interest has not dropped over this time. We've always had a full house, essentially. You can also see another column here in purple. Those are the number of survey responses I got at the end of each semester from students. So I sent them a feedback form where I asked them extensively for all sorts of different feedback about the course. And for example, the numbers I was showing previously were a part of that feedback. As you can see here, about 30 to 50% of students tended to send in that feedback form. Let's look at a bunch of other things that students have sent in as feedback. So one of the questions I asked is what resources have they used to learn Kotlin other than the materials provided within the course? Well, there was, of course, the official documentation. Then there was the documentation for the various frameworks they've used for their homework, Stack Overflow, YouTube tutorials. Within YouTube tutorials, something that got a mention was the Kotlin vocabulary series on the Android developers channel. So that was a great learning resource for students. It has really nice short videos about specific language features. One student mentioned hyperskill.org, also branded as JetBrains Academy. This was actually something I didn't know about, but as you can see on the image here, these are courses where you can learn to code in different languages by building working applications. And I've had students who learned a bit of Kotlin from here. They also mentioned using play.kotlinlang.org, the Kotlin Playground feature, which allows you to write and execute Kotlin code in your browser. This is also a very handy tool that I tend to use a lot, so I wasn't surprised by this. Within the same site, you can find the Kotlin koans. Again, this was something I used when I was learning Kotlin initially. There are a set of exercises that teach you about various language features. This was also super handy. There are some other things within this same site, though, that I didn't know about. For example, there's this Kotlin by example page where you can go through a lot of language features and read about them by looking at code snippets that are explained for you, and you can also execute those in place. And there's also a huge hands-on section within the same site, which has about a dozen different guides, code lab style guides that teach you how to build Kotlin applications of various sorts. Something else to consider for education is the EduTools plugin. Again, this is something I haven't used yet, but I was very aware of this. It's a great way of preparing exercises for students that they can then solve within the IDE. But unfortunately, I just simply hadn't had time to prepare exercises like these. All right, more feedback. I asked students what their favorite parts of the course was. So here are the most commonly mentioned things. The top mention was that I was showing everything through examples. Students really enjoyed the live coding aspect. Then, of course, it was the homework assignment. It makes sense that if you want to learn to code, you have to actually code to do that. They also enjoyed the written materials. Again, they served as an alternative to lectures. So if someone didn't want to attend those and they preferred learning from written content, they could completely do that. Then a couple mentions of Kotlin language features. Functional programming was very high on the list of things that were mentioned. A lot of the students encountered functional programming ideas first within this course, and they were very excited about it. Very similarly, coroutines were hugely popular, even though it was only covered in the very last lecture. They also enjoyed looking at Java bytecode a lot and diving into details of the language's implementation on the JVM. And inevitably, they mentioned the progress bar plugin that I'm using in my IDE, which, if you want to entertain your students a bit, you can also grab from the plugin marketplace. Okay, some more student feedback, which was just free-form feedback at the very end of the feedback form. Students mentioned that they've never seen live coding like this in a course before, which is honestly a shame. I think we should be teaching most programming languages in these kinds of live coding setups because it's very effective. There were students saying that it was their most elective course so far, most useful elective course so far. There was someone who finally understood lambdas after seeing it in other courses and in other languages. Again, this was something I dove into the implementations of, and we were looking at the bytecode a lot, and I assume that's what finally made it click. There was a student who basically wrote marketing copy for me. I'm not making this up. They wrote, they didn't just learn the language, but also the design decisions behind it, as well as the IDE's capabilities. Very nicely put. Just like there were people complaining that the test isn't hard enough, and there were people complaining that we only had a single lecture and then a single test, as well as the homework assignment for the course. There were people who wanted it to, instead of a 2-credit course, be a 4-credit credit course and maybe have weekly code labs or weekly assignments. Two last pieces of written feedback. There was an electrical engineer, which is another bachelor's degree within the faculty, who said that they realized that they wanted to move into coding instead of electrical engineering, and this was one of the courses that reinforced their decision to do that. And also, the funniest piece of feedback that I got was this person who said that they were looking for copper but found gold. Apparently, they just wanted to take a quick filler course for their last semester because they needed 2 more credits. But then my course turned out to be actually useful for them, which is, nice to hear. I had students rate the course on various aspects, but I also asked them to just rate it overall. And over the 4 semesters, this is the average rating that I've managed to get. To sum up the things that I did to make this course enjoyable for students, first of all, meet students where they are. I had live lectures, but I also provided recordings, and I provided those recordings in many places. So whether people could attend at that time or not, they could participate in different ways. If someone didn't like those, they could also use the written materials, which again were completely enough to just prepare for everything in the course based on those, if you didn't like the lectures, and so on. I wanted to make sure that I teach more than syntax. Again, a lot of diving into the bytecode, a lot of explaining the design decisions behind the language. This is the sort of thing that's hard to come by as knowledge. You mostly have to dig this out of old Kotlin Conf talks and things like that. So that's, I think, very valuable for students. And finally, just put students first. There are so many other courses that are difficult to complete at the university and that have very high expectations of students. My goal was more to introduce them to Kotlin and make it an enjoyable experience for them. I was communicating a lot. I was very open for feedback. I tried pulling them into the lectures as much as possible with the live coding. And of course, I had no super hard requirements for them to complete. The idea here in general was that Kotlin is fun on its own, so I should probably make the environment where they are learning the language also just as fun. As a bonus for putting students first, here's me before boarding a plane, opening up IntelliJ IDEA to do things for the course. Okay, 2 more slides before we're done. First of all, I want to acknowledge that everything's a remix. I didn't come up with these things that I practiced during the course on my own. I, as a student, attended various courses that were really fun for me, and I try to replicate that kind of experience as well. So there's the obvious mention of the Android-based software development course, which was just very enjoyable and sparked my interest in Android a lot. And I also have to mention the modern C++ programming and the server-side JavaScript courses at the university, both of which had live coding, which was very engaging for my studying taste. And they also both made sure that they teach more than just the language itself. So they taught things like functional programming and general programming concepts like that. Okay, final slide. Here's a incomplete summary of places within the university where Kotlin is being used today. I'm happy to say that this is incomplete because when I started doing Kotlin things at the university, I knew about everything Kotlin related that was happening. But by now, so many places are using it that I can no longer keep track of it, which is the ideal scenario. So of course, the Android and Kotlin courses use it. The mobile and web development course, which again has 400 plus students each year, and every single person who's doing a bachelor's in computer engineering has to take it, is also in Kotlin now when they're teaching Android development. So you can no longer get a degree at the university without encountering Kotlin, which is, a pretty nice thing. Then there's also the minor on the master's degree that has a bunch of different courses in Kotlin. And to mention just one example that's outside of the department that I was covering so far, there is a 3D graphics course where they are using Kotlin.js so that they can use nicely typed APIs for working with WebGL. This used to be just written in plain JavaScript, but they wrote Kotlin wrappers for it. Whew, okay, that's the end of the talk. If you want to grab these slides or any of the resources or plugins or whatever I mentioned along the way, you can go to the talks page on my website. You'll find all of that laid out right there. And if you want to hear a lot about Android and Kotlin things, you can also follow me on Twitter. That's it. Thank you so much for attending today.
Thank you so much, Martin, for this wonderful presentation. I think it's great that you shared so many examples of what the tools were, what exactly you used during the course. I've been collecting some questions, so now let's have a Q&A portion of the webinar. And if you haven't already submitted your questions, please do so now. Your questions will help us broaden and deepen the conversation that we are having today. And I've noticed that we've had several people who were expecting a course, a learner's course in Kotlin. Today's session was mostly focused on educators. So Martin, maybe you could advise us some resources, if there are any available openly, that we could send some links to into the chat, like a GitHub repo or books or something we could recommend to those who would like to start learning Kotlin.
I mean, there are so many resources that it's really just hard to figure out where to start at this point, which is a good thing, because just like I've mentioned during the talk, if you have a particular learning style, if you can find resources that fit it, like whether you want to watch video courses or whether you want to read a book on its own, it's really nice that you can go through that. In terms of books, I'm still recommending Kotlin in Action, which I have here. That has been the best learning resource that I've had myself. I think that was the top thing that I learned Kotlin from originally. If you want to learn via videos, again, obviously the official Kotlin YouTube channel will probably have you covered, as well as the Android developers channel. That's also very useful with a lot of Kotlin-based content.
Right. I'll just now send a link to the chat with some resources for teaching Android in Kotlin, and there are links to code labs and an entire course for all the levels of programmers for learning Android concepts in Kotlin. Here I sent this link now, and there are some more questions and comments. For example, about all live coding from Alexander. So it was not going well for him because there was no feedback and no way to test if the pace was okay. How did you encounter this problem yourself, and how did you tackle this?
Okay, so I assume that they were teaching remotely, since they were saying that there was no feedback. That's a very hard part of remote teaching to tackle. I've also had lectures where students were just not very active. Maybe it was at the end of the semester and they were very tired and they wouldn't participate so much. So I was just talking to the camera for 90 minutes and had to figure that students are hopefully still following along. What I tend to do is I tend to stop between major sections of the material, maybe every 30 minutes at most, and just ask students if they've understood everything so far, if they have any questions about the section we've just covered before we move on to the next one. It's it's very difficult to get feedback if you can't see your students. You're also not going to make all of your students happy at the same time. So whatever you do, you're always going to get both, this was too basic and too slow for me, and also this was going a bit too quickly and I couldn't follow. If you're teaching a large crowd, that's always going to happen. You just want to stay somewhere in the healthy middle.
Okay, thank you. And another question from Alexander about problem repositories to check students' progress or plans, or do you know of any repositories with problems that other educators could use or learners could use to practice or educators could use for teaching?
Okay, that's a tough question. I don't think I know of anything like that. The closest thing I could say is the Kotlin koans. Yeah, that's all I got for that.
Yeah, and we're also creating some videos from the Advent of Code. Advent of Code is a series of puzzles, and our developer advocate Svetlana Isakova, for example, she has just recently published a couple of videos where she solves these puzzles and explains some fundamental Kotlin concepts along the way. And you can find them on this YouTube channel, and I also shared a link in our chat to this set of videos, and there will be more. Alexander also asks whether it makes sense to make recordings in English, um, because he was doing recordings in Russian. So I would say that we are happy to feature the content that educators create around Kotlin, and we are right now working on creating this repository of educational content that other educators could refer to. So if Alexander wishes to create some lectures in English, they will be available to a broader audience, and we're, of course, will be happy to feature them in the resources section of kotlinlang.org/education website. Another question about the plans to record the courses you were talking about, Martin, in English and make it available online on Udemy or JetBrains Academy.
I haven't done that yet, but it's something I could do. It would be a bunch of work to record, and if I was publishing the recordings, I wouldn't want to just talk for 90 minutes. I would want to like break it up into small sections and have it edited and everything. I might eventually get around to it.
All
I'm
right.
not making any promises.
Okay, and a question from Yosef, whether it's possible to share your teaching materials to adapt for other students.
Oh, yeah, the materials are not public for now. They're only accessible for the students who sign up for the course. But if you have any questions about the things I teach, you can DM me about it. For example, the Kotlin Lang Slack is a great way to reach me.
Yes, we have on the kotlinlang.org/education page, we have links to join communities of educators. And for example, we have this Slack channel for educators where Martin is there and is happy to answer the questions. Another question from Ryan, whether you have a specific process for planning lessons. If so, what is it?
Well, I had a process for creating the material, and then for the lessons itself, I just go through all of that in order. So the lectures are almost just me reading my materials, but a bit more active and involved than that. For the material, it was well, I basically just listed everything I wanted to teach about the Kotlin language. I organized it in order, making sure that I can cover the earlier parts without introducing the later parts, so that I don't have like a mixed level of complexity. And yeah, that was mostly it. It was mostly a like top-down design approach.
Okay, and I think we've covered all of the questions. If there is anything you would like us to cover before wrapping up, please let us know in the chat. I think there were some questions about some actual Kotlin topics about delegated properties and Kotlin generics. I don't know if you can briefly sum this up and explain a bit about the concepts, or maybe point the person to resources where they could find out the answer.
First and foremost, I would point you to the official Kotlin documentation for both of those things. And if you want to see practical things about delegates, if you visit my website, you'll find a couple talks and a couple articles that are about delegates. It's a feature that I've played around with a lot.
That's great. And now I think we've covered all of the questions, and I'd like to ask our viewers to fill in a form about this webinar to let us know about their opinion, whether they learned something new today, whether they wanted us to cover some other topics in the future. And here is the link. Yeah, please send us your feedback. This will help us make these webinars more useful for you. And now let's wrap up. Once again, I want to thank Márton for this great presentation, for sharing the information about your journey of bringing Kotlin to your university. Thank you for answering our questions. We really appreciate that. And thanks everyone for joining us. Send us your feedback. Check out our kotlinlang.org/education page. Join our Slack channel for Kotlin educators. Subscribe to this YouTube channel to hear about the upcoming events. And thanks again. Take care, everyone.
And thank you so much for having me, and also for all of the general education stuff around Kotlin. It's really nice to participate in this.
Thank you.